Hey mathematicians, it's me, Miss Montague. I'm happy you're here today. We're going to go ahead and dive into two mathematicians' work from our class. Just some of their thinking that they did yesterday about the aquarium. What would be the best aquarium for the fish, and then what would be the worst aquarium for the fish. And we're going to make some noticings about their dimensions and what their models look like. And then we are also going to explore a resource that Miss Pletty found for us that's going to help us visualize volume and even add to our understanding of volume a little bit. So we're ready even for 6th grade. So this is going to be a challenge. It's going to be really exciting. Okay, so let's dive into some mathematicians' work. Okay, here is the first mathematician that we're going to look at. What do you notice about their height, length, and width of each fish tank? They're saying that the top fish tank is the best, 10 by 6 by 4, and this bottom fish tank is the worst because it's 24 by 10 by 1 foot, or 1 cubic feet. Okay, so let's go ahead and zoom into this bottom fish tank. Why do they think that this is the worst aquarium for the fish? It has a width of 1 foot. That's it. So the fish would not have a lot of room to swim around, like back and forth. They could swim up and down because the height is 24 feet and the length is 10 feet, but it only has a width of 1 foot. Very interesting. And then this top one is the best. They also recorded their thinking as a mathematician. This one has more space, or has tons of space for the fish to swim around. So even though that both of these aquariums have the same volume of 240 cubic feet, the shape or the dimensions are going to make each aquarium look different. What? Okay, here's our second mathematician. What do you notice about their work? Something that I think was really funny that this mathematician did is that the fish swimming in this aquarium, the aquarium that's 10 by 8 by 4, are smiling, and the fish that are swimming in the 2 by 2 by 60 or 60 by 2 by 2 are frowning. She thinks the happy fish live in this tank and the sad fish live in this tank. I love it. What a fun, creative way to record your mathematical thinking. Okay, so this fish tank, the bottom fish tank, is really long. It has a length of 60, but the height is pretty short and the width is really short. So the fish just don't really have a lot of room unless they swim back and forth, back and forth. They can't swim up or down. Very interesting. I like that this mathematician drastically changed their model based on the dimensions. So they were precise as a mathematician because they made their model reflect the dimensions that they were showing.
Alright team, so this is cubes and I wanted to show you how to use this so that it best works with your iPad. So you're gonna go to right here when you get to the bar for like the search bar. If you click on those little A's right there, you'll actually click on the little A and it'll take it down to 85%. And that's going to make it a lot easier to do some of the stuff that we're working with. And after that, you're ready to go. Alright, so with this, I wanted to show you a couple of things that you can do. So these are called nets, and nets are basically taking a three-dimensional object and flattening them out to show you how much space it takes up, like in a flat two-dimensional way. And so this, if you tap on the sides, it's actually going to build that box for you, or build that rectangular prism for you. And so you now see the rectangular prism that you've normally seen when it comes to volume. And so the question here is looking at how many cubes would fit inside of this space, or how many cubes make this into a solid object. You'll also notice that it says width, depth, and height. And if you look here, the depth that they're talking about is what we have been using as width. And depth is the amount of space it takes up from front to back, or the amount that it's taking up like on a shelf. So if I was placing something on a shelf, it would be how deep is that shelf and will that object fit or not. Width in this app is known as what we've been calling as length. So you'll notice the 4 purple across, that they're calling that width. We've been calling that length. And then width, what we've been calling width, they are calling depth. And so you'll notice that there are 5 red blocks going across, and that is the depth. And then the height is the 3 high, so the 3 purple, or 3 levels high. So I'm going to actually open this container up again, and I want to find out how many cubes can fill this container. First of all, I could figure that out by doing the formula for volume, but really what I'm trying to understand today is how do I know that this is a solid shape that I can fill this in. And so one way that I can do that is I can click cube, and you'll notice that there's a cube that got placed there. And I can continue pushing cube until I run out of cubes to use. And now I've clicked cube, and there are no more. And so then you're going to notice there where it says cubes, it says 60, and it takes 60 cubes to fill this container. I can close this container up around those 60 cubes, and you can see that that is a full container now. If I were to multiply 5 times 3 times 4, I would get 15 times 4, or I could do 15 times 2, which would be 30, and then 30 times 2, which would be 60. And so you can see that there are 60 cubes inside of that container there. So I can clear that out, and I can mess with another one if I'd like to. So I can click the next arrow. So I could find the volume of that and check my work by putting in the cubes, which this one would be a lot of cubes. But I think this is a really cool app because it actually shows you what it looks like when the dimensions are 17 by 8 by 4. What does that look like? What does this look like when I have 7 by 17 by 14? So what would that actually look like? Which is super cool. So let's say that I wanted to actually see what the dimensions of my own aquarium might look like, or my own rectangular prism. Well, here, this is where we click on the wheel, and this is why it's really important that you're at 85%. So I'll show you again with those A's. Make sure that you've clicked the small A to get to that 85, or it won't work. Okay, so I'm going to click here, and I'm going to actually try this out now. So I want my width, which in this situation, remember, is like the length. I want it to be 5. I want my depth to be 4. And I want my height to be 10. Okay, and so it's actually going to make it for me. And that's what it looks like. So this is what, let's say that these were the measurements of an aquarium that I did. Well, that would be what my aquarium would look like. And so I like to be able to see what it looks like. And now I want to find out how many cubes it's going to take to fill in that aquarium. So I can do this, and I can see how many cubes all the way if I want to. Another cool thing about this is layers. So look at that. Look at that first layer. That is a 5 by 4 layer, which means that there's 20 blocks there. And now I can figure out how many layers of 20 it's going to take to fill up that container. All right, team. So that is the tool. Be ready. We're going to use this tool, and I'm going to ask you to use this tool and post some pictures on what you're doing. And so play with it, mess around with it, and this will be helpful as we move forward into our aquarium work and our volume work.